In this video, we're going to start chapter 4. And chapter 4 is on alkanes. And if we remember from our functional groups, alkanes were hydrocarbons, so they just contain carbon and hydrogen only. And then we had said that all of the bonds between the carbons were singly bonded. So no double bonds, no triple bonds. So just carbon-carbon single bonds. So all carbons have single bonds. And if it wasn't cyclic, we said it was saturated. To be saturated, it follows that formula CnH2n plus 2. So you would take the number of carbons, so an example, I'm just randomly picking 8. So if I have 8 carbons, to figure out the number of hydrogens that it would have to be saturated, I would take 2, multiply it by 8, so that's 16, and then add 2 to it. So I would have to have 18 hydrogens. So if you were given this formula, I know that it's a saturated hydrocarbon. I know that it's an alkane. So we could also have cycloalkanes. And remember, cycloalkanes, they're still alkanes, so still just carbon and hydrogen. All of the carbons still have single bonds between them, but they're forming a cyclic structure. When they do that, they're no longer saturated. They're not going to follow that formula, right? If I was to take those 8 carbons, let's actually draw these. I think that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Those end carbons, right, would have 3 hydrogens on them. None of them are charged, so I know I have 4 bonds on each of those carbons. So I would have 3. If I wanted to make a ring out of those, so if I wanted to connect this carbon to make a cycloalkane, I would actually have to remove a hydrogen from each of those carbons to do that. Otherwise, I would have too many bonds. So if I wanted to take 8 carbons and put them in a ring, it's going to look like a stop sign. I'm not very good at drawing stop signs, but there's my cycloalkane, and I'm only going to have 2 hydrogens, right, on every single carbon. I'm not going to have ones on the end where I have 3. So this cycloalkane is going to have the formula C8H16, not 18. So as soon as we make a ring out of it, it's no longer unsaturated. So cycloalkanes, they're still hydrocarbons, right? They're still carbon single bonds, right? It's still an alkane. So those things that define our alkane are still true, but these guys are considered unsaturated. They would have the formula, if they're just single rings, CnH2n, right? This is C8H16. The main focus of this video is actually going to be naming, and we are going to use the IUPAC. It is an acronym, so it should all be capitalized, System of Nomenclature. Nomenclature just means a system of rules for naming, and then IUPAC is the body that has come up with these rules that we're going to use. It stands for the International Union of Pure and Applied Chemistry, or Pure and Applied Chemists. You don't need to know the acronym, it's good to know what it means. But essentially, it's a group of really smart people that got together and they come up with the rules that we're then going to follow for naming organic molecules. So IUPAC nomenclature. So just the system of rules that we're going to use for naming organic molecules. And it is based on the number of carbons in our parent chain. And I know I haven't defined parent yet, but I will. So if something is just straight, if it doesn't have any branches, then that is our parent. So if I was to just do 5 carbons in a row, I have 5 carbons. So it's based on the fact that I have 5 carbons. If I was to do 4 carbons in a row and then put a branch on the second carbon, my parent is going to be those 4 carbons. So the name is going to be based on the fact that I have 4 carbons in my parent chain, and then I have a 1 carbon branch. So based on the number of carbons in the parent, but also the number of carbons in my branches. So I do have a handout for you. I'm going to pull it up. It is posted on Canvas on the page where I have practice problems. That's where I'll always post handouts also if we have any. And this is our second kind of list of memorization. So we had our functional groups, and now we have these. So if it's going to be based on the number of carbons, we need to know what name goes with that number of carbons. And most of them are pretty familiar. So when you learn to name covalently bonded compounds, right, we used prefixes. And from 5 on, they're essentially the same. So when you are naming in 151 or 130, if it had 5 carbons, penta, there was an A at the end of it is what we used. 6 was hexa, 7 was hepta, nona, skipped octa, deca. It's the same, we're just getting rid of the A. So 5 is pent. A pentagon has 5 sides. You can use geometry if you want. 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. So those have not changed from what you've learned before, with the exception of getting rid of that A at the end. That A is no longer there. The only ones that are probably truly new for you are the first 4. So 1 is meth, 2 is eth, 3 is prop, and 4 is but. So you do need to memorize these. We are going to be using them for every single functional group that we name. The only difference between like naming an alkane and naming an alcohol, there's a few little ones, but it's essentially going to be the end. So when we're naming an alkane, it's going to end in A and E. So methane is a 1 carbon alkane, right? Meth is 1, ane means it's an alkane. Propane, right? Prop is 3, is a 3 carbon alkane. If I had propanol, I have a 3 carbon alcohol. If I have propene, E-N-E, that's going to be my ending for alkenes, it's going to be a 3 carbon alkene. So these prefixes are going to be the same for every functional group that we do. We're just going to change the ending based on what type of functional group we have. So propanone is a 3 carbon ketone. So while it looks like a lot of memorization right now, you don't have to do it again. Like once you learn these, we're going to use them in every functional group that you learn to name. So some rules for naming. We're gonna come back to this stuff I'm skipping through, so we'll come back to that. So for non-branched alkanes, so just straight chain ones is how I usually call them. Non-branched is probably better because they don't have to actually be straight to be a straight chain alkane. Oop, I meant to erase. So straight chain, but remember it doesn't have to be straight. It just has to not have any branches on it. So if I look at this first one here, I have 5 carbons, 1, 2, 3, 4, 5. If we go back up to that table, 5 is pent. It's an alkane, so it ends in A and E. So pent, ane, right? We just take the number of carbons, we take the corresponding prefix, and we throw the appropriate ending at the end. This has 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. 8 is oct. We throw ane at the end of it because it's an alkane, so octane. What I mean by they don't have to be straight, I could draw 5 carbons like this, right? It's still just 5 carbons, it's just that that last carbon is now going up instead of down. We talked about these when we were doing isomers. If I was to name this one, it's still just 5 carbons in a row, so it's still just pentane. If they have the same name, they're not isomers of each other, they're actually the same. Like identifying constitutional isomers is actually easier once you know how to name things, because if the name is the same, they're the same. They'll only be isomers if they have different names. So non-branched ones that are straight, even though, right, This is the whole, like, if I was to take my arm and hold it straight out or hold my arm straight up in the air, it's still attached at the same point, right? To make it different, I would have to like cut my arm off and attach it to some other body point. So they're the same, it's just I've rotated that bond, right? We can rotate bonds, they're not stationary. So count the number of carbons, add A and E to the appropriate prefix, and we're done with those. Where it gets a little more complicated is if I have branches. So that one where I had 4 carbons and I put the branch on it. So we're going to go through these rules. I'm going to go back out to my regular blank page so I can do examples, but I will be flipping back and forth to these rules. Because they're written here, I'm not going to rewrite them. So if you need to pause the video to like write them down, or if you want to pull out this handout and print a copy for yourself, again, it is posted on Canvas on the practice problem page of this module. Whatever you need to do, because I'm not going to be writing them and I'm just reading them, I'm going to be doing it kind of quickly. So if you need to pause to have time to write it down yourself, by all means do that, or just go get the handout yourself. So for branched alkanes, the first thing we need to do is we need to find our parent, right? Our name is going to be based on the number of carbons in the parent, so we have to find our parent. The parent is going to be our longest continuous chain. It does not need to be straight, however, it just needs to be continuous. I'll give us some examples here in a minute. And then if I have 2 chains that have the same length, I'm going to choose the one with more substituents. And again, I will do an example. And then I generally circle the parent. I'm probably going to highlight it because it's easier on this iPad, but circle it, highlight it, somehow mark the parent. Once we start doing, steps 2, 3, 4, and I can count 2, 3, and 4, you're going to probably be glad that you have that parent identified. So I'm going to find the parent. I'm going to highlight it, but circle the parent. If we were in class, I would circle it. So I'm going to go back out and we'll do some examples. So I'm just going to draw a couple here and then we'll go through finding the parent on it. Let's do one more. This last one I'm going to actually copy from your handout. I wanted to do different examples, but this is a good one. Okay. So I don't know, I can do the first couple with you, or if you want to pause it and find your parent yourself and then come back and see if you get the same thing I do. Again, we're looking for the longest number of carbons. So like the first one, this one's just going to be straight across, right? If I count the number of carbons that I just highlighted, 1, 2, 3, 4, 5, 6 carbons. And then let's get rid of that. If I would have gone this way, because remember, it doesn't have to be straight, it just has to be continuous. If I would have done that, 1, 2, 3, 4, 5 carbons. Since 6 is bigger than 5, and I want the longest chain, I'm going to go with my original. So if I were you guys and you don't have like a highlighter, I would circle that. I'm going to highlight it though. Ooh, highlighter. So that's my parent for that one. So go ahead and give the other ones a shot and then come back and see if you get the same thing as me. Okay, hopefully you did that. On this one, I am actually going to go up. If I do that, I end up with 1, 2, 3, 4, 5, 6 carbons in my parent. If I would have gone straight across, let's actually do it in orange. If I would have done this, then I only have 5 carbons. And again, I want the longest chain. So that's the one. This next one, if I'm just going in order that I have them on the iPad here, this is probably the kind of the trickier one. This one, we're actually going to go this way. If I do that, I have 1, 2, 3, 4, 5, 6, 7. I don't know if you guys counted that with me, carbons in my parent. If I would have gone straight across, the orange one, I'd have 1, 2, 3, 4, 5, 6 in my parent, so 7 is bigger. If I would have gone this way, 1, 2, 3, 4, 5, 6 again, so 7 is still bigger. And there's actually only one more option, which is much shorter, but we could have done that. 1, 2, 3, 4, 5. So my yellow one is the correct answer. Again, they just need to be continuous, not straight. This is an example of something that kind of curves around, but they're continuous. So that's going to be my parent for that one. This one, I'm actually going to go straight across. And I'm going to redraw this one, and we'll do it again a different way. But I have 1, 2, 3, 4, 5, 6 if I go this direction. I'm going to redraw it because some of you might have gotten this. If I go this way, I also have 6. Do you guys see that? 1, 2, 3, 4, 5, 6. I just put some dots on there. So for this one, for both of these, I get 6. If I go back to those rules, we had a rule that said that if we have parents to write 2 chains of equal length, choose the one with more substituents. A substituent is just our branch. So anytime I have something coming off the parent, a branch point, that's a substituent. So substituents is a branch, same thing. So I want to choose the one that has more branches coming off of it. So if we go back to that example and I look at these two, let's highlight my substituents in green. This one on top, I have a branch here and I have a branch here. So I have 2 branches. This one, I only have a branch here. That branch branches, but I only have 1 branch coming off that group. So I want the one on top. The first one I did was correct. So not this one, right? This has 1 substituent, a 6 carbon parent. This one up here has 2 substituents, 2 branches. It's also a 6 carbon parent. So we had 2 parents, right, of the same length. They were both 6 carbons, but the one on the bottom only had 1 branch. The one on the top has 2 branches. I want to pick the one that has more branches, more substituents. So that one on top is going to be the correct one. I just wanted to get rid of that highlighting. So that was messy. So that's the one I want. That would be the correct answer. One more. This one I'm going to, not do that. Sometimes you get the wrong one. You have to go back. Oh, geez. Okay. This one, I'm going to go here. Right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons if I do it that way. If I was to go the way I started, right? I have 1, 2, 3, 4, 5, 6, 7, 8. 9 is bigger than 8, so we want to do that. If I just went straight across, I only have 7. Again, 9 is bigger. You can come up with all of the combinations you want. This is going to be the longest one. So that was my first step. Find my parent. Parent is my longest continuous chain. Again, it doesn't have to be straight. I have a couple that curve around. If you have 2, right, that have the same length, you're going to choose the one that has more substituents. If they have the same number of substituents, then pick one. We're actually going to end up with a similar name. We'll have to use another rule, But if the number of substituents are the same, then pick whichever one you want. It doesn't matter. Let's go back out to our directions here because we're on to step 2, right? We've already found the parent and we've numbered our parent. Sorry, we found the parent. Now we're going to number the parent. So that's our second step. So some rules for numbering it. And by numbering it, I'm literally going to take my pencil and I'm going to write numbers on every single carbon in my parent. So I'm literally going to number it. So our rules. We want to start closest to the substituent. Again, remember substituents are just my branches. I have to start on an end, but I want to start at the end closest to the substituent. So if there's one substituent, I want to start at the end closest to it. If there's more than one substituent, I want the lowest sum of carbon numbers. And this should make more sense when I go through the examples, but I want the lowest sum. So I'm going to assign carbon numbers and then I'm going to literally add them together where the branches are, and I want them to have the smallest sum. And then the last step, if the numbers for the substituents are the same from either end, I'm going to number them alphabetically, which I know might not make a lot of sense to number something alphabetically, but our branches are going to have names, and I want the one that comes first in the alphabet to have the lowest number. The names are going to be based on the number of carbons in that branch. So if we go back up to that table where I have my prefixes, we're going to use this for our branches also. So if I have a 1 carbon branch, it's going to be meth. I'm going to put a different ending on it, which we'll get to in a minute. If I have a 2 carbon branch, I'm going to use eth. Since E comes before M in the alphabet, I would want an ethyl group to have a lower number than a methyl group if my numbering is the same from either end. That's kind of like our last rule. So if we go back down, I want to have the lowest, right? Lowest sum, that's first. And then if, big if, if the numbers for the substituents are the same from either end, then we're going to number it alphabetically. And again, I will do examples in a minute. Back up to these guys. So the names for my branches, based on the number of carbons, so meth if there's 1, eth if there's 2, but then my ending is going to be YL. So an alkyl group is just a carbon-based substituent. So on all those examples that we did, every single branch on there is an alkyl group. So a substituent is a branch, right? If that branch is made out of carbon and only carbon, then it's called an alkyl group. Because alkyl ends in YL, I'm going to put YL at the end of it. So if I had a 1 carbon branch, let's just do an example here. Right, so I would go through, I'd find this as my parent. I have a 1 carbon branch here, right? There's 1 carbon that's attached to my parent. That's meth. Because it's a branch made out of carbon, it ends in YL. So that would be a methyl group. Again, we will put all the names together, so we'll come back to that. We just need to know that it starts with M. So when we're alphabetizing, if we need to, we know what to alphabetize it on. We are going to, might as well do this now since we're here. I am going to name alkyl halides in this section also. Remember, alkyl halides, I had a halogen attached to an sp3 hybridized carbon. So if I was to go and stick a fluorine on here, I'm going to name them just like I would name any other alkane, except instead of having an alkyl group, right? Instead of having a carbon-based substituent on it, I'm going to have a halogen. So if I have a fluorine attached to it, the name of that group, if I was alphabetizing, or when I put the name together, is going to be fluoro. If I have chlorine, chloro, bromine's bromo, and then iodide is iodo. Iodide things always sound weird. So if we had to alphabetize our branches and I had a fluorine, I would alphabetize it based on the F and so on. Okay, so let's go number those parents. Let's go back out to our example. So grabbing blue. So this one, if I go from the left, 1, 2, 3, 4, that branch is on carbon 4. If I go from the right, 1, 2, 3, that branch is on carbon 3. And our rule said if we had one branch, we want to start at the end closest to it. So that's the direction I want to go. So that's going to be my correct numbering for that first one. This second one, I have 2 branches. So if I start from the left, 1, 2, 3, 4, 5, 6. So I have a branch attached to carbon 2, right, an alkyl group. I also have a branch attached to carbon 4. And if I add those together, remember I want the lowest sum, sum means you're adding, I get a 6. If I was to number from the other direction, so the green letters or numbers, 1, 2, 3, 4, 5, 6. So according to these, I have a branch on carbon 3 and a branch on carbon 5. And when I add those together, I get 8. Because 6 is a smaller number than 8, it's the blue numbers that I want. I want the lowest sum. So I'm going to get rid of these green ones. I'm going to put my highlighting back. That's going to be the correct numbering for this one. So I numbered it from both ends, right? I added the carbon numbers where the substituents are. And when I do that, I get 6 for one direction, 8 for the other. 6 is a smaller number than 8, so that's the one I want. So you guys try this next one on your own, and we'll see if we get the same thing. So by next one, I'm just going straight across this one. So this one I'm going to start at the top. 1, 2, 3, 4, 5, 6, and 7. So my branches are on 3 and 4. If I went the other way, 1, 2, 3, 4, 5, 6, 7. They're on 4 and 5. That adds up to 9. This adds up to 7. That's the one I want, not that one. So let's get rid of these again. Oops, I certainly didn't want to erase all that. Let's put the parent back. Okay. This next one. Right, if I went the other way, 1, 2, 3, 4, 5, I've had branches on 4 and 5, not 2 and 3. My last one, we're going to go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a branch on carbon 3 and I have a branch on carbon 6. If we would have gone the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a branch on carbon 4 and on carbon 7. That's 11. This is 9. The blue numbers are the ones I want. I do want to give us one more example where we have to use that alphabetical. So let's draw one more down here. So I'm going to put one carbon group there and then a 2 carbon group here. My parent, I'm just going to go straight across. If you wanted, we're going to get the same name. If you do this, if you want to do that, it's going to be the same thing. Either way, I have 7. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8 carbons in my parent from either direction. And then when I go to number this guy, if I go this way, 1, oops, not highlighter. If I go this way, 1, 2, 3, 4, 5, 6, 7, 8. So I have a substituent on carbon 3 and I have a substituent on carbon 6, right? Those are the carbon numbers where those branches are coming off. If I go the other direction, 1, 2, 3, 4, 5, 6, 7, 8, I have a branch on carbon 3 and a branch on carbon 6. So either one of those, it adds up to 9. So this is where we need to use that rule that says to number them alphabetically. So I need to name these substituents. So this branch right here has 1 carbon on it, right? There's 1 carbon attached to that parent. 1 carbon is meth, and then it's a carbon-based branch, so it's going to end in YL, so that's a methyl group. If I go look at this substituent, I have 2 carbons there, right? There's a carbon here and there's a carbon here. 2 carbons is S. It's a carbon-based substituent, so it's an alkyl group, so it ends in YL, so that's an ethyl group. I'm going to number these alphabetically. E comes before M in the alphabet, so I want to use the green numbers, right? I want the one that comes sooner in the alphabet to have the smaller number. So I want ethyl to be on carbon 3 instead of carbon 6. So I need to get rid of, let's make my eraser more precise here. I want to get rid of the blue numbers this time. So we're only going to do that if it's the same, right? If I go back and look at this, I have the same sum from either direction. Then I have to pull out the alphabet when that's the case. All right, so that was that step. Our next step is actually going to be to start putting the name together. To do that, we're going to go back out and look at our rules here. So we are now on step 3, and I'm going to do 3 and 4 together. So we'll read through them and then we'll go back to our example. So we're going to identify the location and the name of our substituents. So is it a methyl group, an ethyl group, so on. If I have more than one of the same substituent, I'm actually going to lump them together. So if I have 2 methyl groups, I'm going to say dimethyl. If I have 3 ethyl groups, I'm going to use triethyl. So if 2 or more, I should say, of the same type of substituent, we're going to use di if there's 2, we're going to use tri if there's 3, we're going to use tetra if there's 4. I won't give you more than 4 of the same group. When we put our name together, we are going to alphabetize them. That's down here on step 4. I am not going to use the di, tri, tetra for alphabetizing. So if I have a dimethyl group, I'm going to alphabetize that based on the M for methyl, not the D for di. So do not use di, tri, tetra, etc. for alphabetizing. I do need to include the carbon number for all substituents. So if I'm going to use di, I have to have 2 carbon numbers. I need to say where they both are, even if they're on the same carbon. And when I do examples again, hopefully this will make more sense. Once I've done all that, we're going to actually write the name. And I usually just do step 3 as I write the name. I combine these 2. So some rules for writing the name. And I do take off for this, so be very careful. So I'm going to put a dash, so a hyphen, between numbers and letters. So if you're going to have a number next to a letter, it has to have a dash between it. If it doesn't, we take off because you're not following the rules. The rules, there's going to be a dash between numbers and letters. I'm going to put commas between numbers, and I'll show you when these cases occur, like why you would have 2 numbers together, but it has to have a comma between it. Again, if you don't put a comma between it, you're not following IUPAC rules. I'm going to run all letters together with no spaces. There's a couple exceptions to this, but not in this chapter. When we get to ethers, we're actually going to name them not using IUPAC nomenclature. We're going to name it both IUPAC and not IUPAC, but for the non-IUPAC, you can have a space. And then if you were naming carboxylic acids and esters, you can have a space. So if I was doing a 2-carbon carboxylic acid, it's ethanoic, eth is 2, so ethanoic acid, and you can have a space before the word acid. But we're not naming those this semester. That's in 236. So dashes between numbers and letters, commas between a number and another number. All of our letters get run together with no spaces. And then we're going to, if we have more than one substituent, we are going to list them alphabetically, not numerically, alphabetically. So let's go out to our examples here. So I'm just going to erase some of this extra stuff that's just kind of in our way, just so we have room and it's nice and clear. Okay. The names can get kind of long. So this first one, oh, sorry, let's go back out because you need this. How it's going to be is we're going to, it's this box that I forgot to show you, is we're going to state the carbon number where the substituent is. So if I have a methyl group on carbon 2, I'm going to put a 2 there. And then I'm going to put the name of the substituent, so methyl. Between the 2 and the word methyl, I have to put a dash because I always put dashes between numbers and letters. And then I'm going to put the parent at the end. This part, carbon number and the name of the substituent, I'm going to repeat for all substituents. So if I have 3 substituents, carbon number dash name a substituent dash carbon number dash name a substituent dash carbon number dash name a substituent, and then the parent. And the order that I'm going to put all of that in is alphabetically. So back out. Sorry about that. So this first one, I only have 1 substituent, so I don't have to worry about alphabetizing it. That substituent is on carbon 3, right? If I look, attached to carbon 3, I have a branch. So 3, and then that branch has 1 carbon in it. 1 is meth. It's a carbon-based substituent, so it's going to end in YL. That dash went between the 3 and the M because I always put dashes between numbers and letters. And now I'm going to put the parent name. So what was my prefix for 6? Good, hex. I'm not going to put a space. This is all one word. And then it's an alkane, so it's going to end in ANE. So that would be the name of this first one. Basically what it's telling me is that I have 6 carbons in a row. They all have single bonds between them, right? Ane is for alkanes. Hex means 6. So I have 6 carbons in a row, all with single bonds between them. And then on the 3rd carbon, I have a 1 carbon branch. So 3-methylhexane is the name of that. This next one, so I have a methyl group here, right? A 1 carbon group. I also have a methyl group here. So this was the rule that said if we have 2 of the same substituent, we're going to put them together. So instead of saying 2-methyl, 4-methyl, I'm going to do dimethyl. And then because I'm using di, I have to have 2 numbers, and they're both going to go in front. So 2, and then I have to put the 4. Between numbers, I put a comma. So 2,4 dimethyl. Anytime you have di, you have to have 2 numbers. I have to know where they both are, even if they're on the same carbon. Let's say I had 2 methyl groups on carbon 2. Let's say I had something like that. I would do 2, 2 dimethyl. So if you're using di, you have to give me 2 numbers. If you're using tri, you have to give me 3 numbers. You're always going to put commas between those numbers. So on carbon 2 and carbon 4, I have a methyl group. So 2,4 dimethyl. And then my parent has 6 carbons again, so hex. And they all have single bonds, so ane. So 2,4 dimethylhexane. My next one, here I have a 1 carbon group, so that's methyl again. Here I have a 2 carbon group, so that is ethyl, right? There's a carbon here and a carbon here, so a 2 carbon group. When I put these together, I'm going to list them alphabetically. So because E comes before M in the alphabet, I'm going to do 4-ethyl before 3-methyl. Remember, we're listing them alphabetically. So the name for this one, on carbon 4, I have an ethyl group. I'm now going to list my second substituent, so I'm going to put down a number. So I had to put that dash there, right? Between the L and the 3, there has to be a dash. And then another dash, because I'm about to write a letter. So on the 4th carbon, I have a 2 carbon group. On the 3rd carbon, I have a 1 carbon group. I have 7 carbons total, so hept, and they all have single bonds, so ane. So 4-ethyl, 3-methylheptane. Again, we listed those alphabetically. Be careful when folks are learning, they sometimes want to do the 3-methyl first because 3 comes before 4, but we don't list them numerically, right? We list them alphabetically. That is our rule. If we go back, I think I underlined it quite a few times already. Yeah, I've highlighted it, I've underlined it, circled it, right? We're listing them alphabetically, not numerically. So 4-ethyl, 3-methyl heptane. This one down here, I have 2 methyl groups again. So on carbon 2, I have a 1 carbon group. On carbon 3, I have a 1 carbon group. So 2,3-dimethyl. 6 again, 6 seems to be the number of the day. Hexane. This one I have 9 carbons. On carbon 3, I have a methyl group. On carbon 6, I have an ethyl group. Again, E comes before M in the alphabet. So 6-ethyl, 3-methyl, it's a Y, sorry. 9 is non. Again, run all your words together, so no space there. And then it's an alkane, so ane. So 6-ethyl, 3-methyl, non-ane. Which makes you sound really smart. Like if you're sitting there studying and like someone comes and looks and you're like, oh yeah, 6-ethyl, 3-methyl, non-ane. Like it sounds like you're super smart, but it really means you can count and alphabetize, right? You got some rules, you just have to follow them, alphabetize and count. Of course, you have to follow the rules, right? I like rules because you just have to follow them, right? It's the same every single time. Like you're always going to list them alphabetically. So do that. One more, and then I'm actually going to give us an example that has a halogen on it. So we'll actually add one more after this one more. So this one we've already named our groups. I have ethyl, I have a methyl, so that part's done. E comes before M in the alphabet. The ethyl group is attached to carbon 3, so 3-ethyl. That methyl group is attached to carbon 6, so 6-methyl. I have 8 carbons, 8 is oct. It's an alkane, so it ends in ane. So 3-ethyl, 6-methyl octane. One more, just because I want to do something that has a halogen on it. So let's put a bromine there. I'm going to make this one a little bit harder. Okay, so all of our rules. First one, we're going to find our parent. There's no reason that last carbon got so long. I thought it looked weird like that, but they do have the same length. So my parent, and then once I get here, I can go to any of those. I'm going to go to this one, but it would be the same number if you went to this one here or this one here, if I'm making sense. I'm going to number my parent, and I want the lowest numbers for my branches. So this one I'm actually going to number from down here. We can do it both directions so you can see it. But I have a lot of branches on this one. So I have 2 branches on carbon 2, right? There's 2 methyl groups on there. So I need to count that twice, right? Because I have 2 groups on that same carbon. I have a branch on carbon 3 and I have a branch on carbon 6. So when I add those together, I get 13. If we went from the other direction, 1, 2, 3, 4, 5, 6, 7. This time I have a branch on carbon 2, a branch on carbon 5, and then I have 2 branches on carbon 6. So that adds up to what? 12 and 5 is 17, 19. So because that one that has 2 branches on counts twice, right? Because it has 2 substituents, so I need to include those. I need the green numbering this time. So let's get rid of our blue numbers here. Oh, highlighter. So this one, when I put the name together, I have on carbon 6, I have a bromo. So if it was a fluorine atom, it would be fluoro, right? Chlorine atom is chloro. This is on that little table on the first page of that handout. And then I actually have 3 methyl groups. On carbon 2, I have 2 methyl groups. And then on carbon 3, I also have a methyl group. So I actually have trimethyl. And remember, when we're alphabetizing this, we're alphabetizing it based on the M. The di, tri, tetra don't count. So for alphabetizing purposes, this gets alphabetized on the B, this gets alphabetized on the M. Now, if you goof this one up and alphabetized it on the T instead, you're going to get the same answer. You're going to get lucky even if you don't know that, but that's not always going to be true. So you're not alphabetizing it on the di, tri, tetra. And the way I remember that is the di, the tri, and the tetra are not representing words. They're representing numbers, and you don't alphabetize numbers. I don't know if that helps, but I don't think of tri as a word. I think of it as the number 3. And you don't alphabetize the number 3, right? You alphabetize the methyl. And that's kind of how I remember it. So when I put this together, the bromo is going to come first. So on carbon 6, I have a bromine. So 6 bromo. And then because I have trimethyl, I have to provide 3 numbers. So on carbon 2 is one of those groups. That other group is also on carbon 2. And then the third one is on carbon 3. So 2, 2, 3, trimethyl. I have 7 carbons total in my parent. So hept. And it's an alkane. So 6 bromo, 2, 2, 3, trimethyl heptane.